Hey guys, Wadox Studios here, and today we're going to talk about a multi-directional character for the 2D Skeletal System Tools plugin. So, if you've gotten this asset off of Fab, either the blueprints or the plugin, you'll have a character in your scene, a default character, based on this golem. And his default class is going to be this BP character here. Now, when you hit play in the scene, the default character that spawns on the game mode is going to be this character too. So, like, that's what it's going to look like. And the question was brought up, like right now I'm handling the, in the example, the character essentially just handles the relative scale 3D. So whenever you walk back and forth, it inverts that scale and flips you from side to side. So with a 2D bone system, it's a little bit more complicated than, say, a 4 or 8 directional like flip book, right? So if you have your sprites, you have your sprite sheet, you have a flip book, you can detect the direction based on like a top-down perspective or a front-facing perspective, and you can kind of blend between your flip books based on the angle of direction that you're moving throughout your world. So that's how you see, like, sometimes you'll have a 6-way or a 4-way or an 8-way directional sprite sheet. And in this example, I found a character that was very closely matching the original Golem character. The only difference is that this character has back, front, and side, right? So this was the simplest way for me to show kind of the concepts of going this direction without taking on the task of approaching this from a more complicated direction, which would be designing like a control rig that would flip the orientation of the bones, which would bring the mesh cards with it based on angle. There's so many different ways to skin this cat, but I wanted to show one of the easiest ways using the tool to accomplish this. Now, if you don't have the tools plugin, if you just have the Skeletal 2D system, you're going to have mesh cards. You can still follow along, but you're going to be lacking the conversion utility that the plugin provides to speed your workflow up, and you'll have to do some of this pretty much manually. So I do recommend, if you don't have the plugin, it includes all of the original assets from the asset pack. It just provides you a faster way to get from point A to point B. I would recommend picking it up. Anyway, to start, what I did was, in order to support multiple directions, we have to enable that kind of control. So if you go into the plugin and you go to the input system, you'll notice that you don't, while you do have an up and down, you don't have the W and S key set up. They've been stripped out to prevent you from walking forward and backwards. So you'll need to go duplicate the W and S to match the settings for the up and down. So, I mean, there's really no difference there. You'll just want to add them back into your inputs so that you can have that behavior on a character. It's not going to impact your default character. It's still left to right movement. Nothing about that's going to change. However, when you go and you make a child class off of this, when you create a child blueprint class, that's what I did here. So if we open him up, you'll see he's just a child of the parent BP character. When you do that, you'll want to go to the movement component and you'll want to find constrain, and you want to uncheck this constrain the plane, and that'll allow you to move up and down. The other thing is you'll want to copy the movement input out of the base character into this child to overwrite the movement behavior. And you'll want to rewire X and Y for three-dimensional movement. So basically these are inverted on the parent character. You'll just want to make sure X is following this top path, Y is following the bottom for the movement input. And then over here, we'll get off into this in a second. All of this is pretty much the same, but you'll see I've added these extra two events here, these two custom events to handle the front and side view. And then the only other thing you'll need is you'll want use pawn control rotation on the camera boom, and then on the movement character you'll also want I think it's like inherit pitch to not be checked. You do want yaw and you do want roll, so you want to be able to like rotate left and right, but you don't want pitch because, and I'll go swap to him here in a second. You don't want to pitch your camera up, and you can see already the logic that I put there, but you don't want to be able to pitch your camera up above the character. Like if I go enable that right now, you'll see what I mean. So let's go turn that on. So if I look up, it kind of ruins the facade. For this character, I don't have a top-down perspective, so that adds to the amount of work that I would need to do to blend between these different vantage points. So for this example, we just do not allow that. Actually, y'all was supposed to be there. It's pitch that we don't want. Yeah, so this locks the camera in front of the character. It supports left and right movement, and as you can see, I'm swapping the head and the face. Let me zoom in here for you. I'm swapping the head and the face based on the angle, and then if I walk forward, the character, his head essentially turns around. Now, I haven't completed this for the rest of the body because the concept is the same for the arms, the legs, etc. But I just want to show you that this is the way that you would support multi-directional movement and still be able to have this camera rotation freedom if you wanted it, to walk around in 3D space with a 2D character. Now, how did I do this? So again, we overrode that base character. So that base character came with something that matched my original character very closely. And if we come up to the skeletal mesh, we come over here to visibility, and we unhide him, some things will start making sense. So essentially, this character has the skeleton rigged, and because this other character that I had with the multiple directions matched his rig very, very closely, I decided just to hide the original mesh and use the plugin's sprite to mesh converter to convert the static meshes that I needed, and pulled them into the child character one by one. So we'll set this back to invisible. So the body is here. So if you haven't watched the previous workflows, basically you find a texture, and we'll just do the back right leg. So you find a texture. You would apply the paper 2D sprite settings, right? So that's the first step. Then we can just save it. And then I don't know what that was. Let me see, save. There's an attached child on the arrow component. That's what it's complaining about. So I have this, I wanted to be able to see the direction of my character, so I have an attached arrow child on an editor only object, and it complains about that. So this guy here, which is fine. Don't worry about it. It's just there for testing an editor so I can see which direction my my capsule was facing when I was walking around. So it's just a way for me to keep up with coordinates. But anyway, back to the thing here. Child. So we have the mesh hidden, but as you can see, I drugged this static mesh body in. The workflow for that is you would apply the paper 2D settings for the texture. You would then create the sprite from it. You would then name this according to what it is. So this is right leg back, basically, instead of sprite. And then you would use the plugin tool to convert it to a static mesh. What I was doing was moving it into my sprites folder first. So I'm moving it here. So I have right leg front, and then I have right leg back. And then from here, I would convert to static mesh. It does this step automatically, places it in here. And then it gives you a material that you would then need to rename to back. And then I would slide this material in here. So as you can see, I have a material for each stage, and I have my right leg and my right leg back. I did that for my head, so that's how I got the head, front and the head back. And then I have a side face and a front face. And then I think that's pretty much it. I'm just flipping the character card to get the inverse for left to right movement, and then the head back, and then the normal head, which is technically the front, is how I'm getting that. So we'll go take a look at that logic here in a second. We'll make our way down this hierarchy so you can see. Basically, you drag those static meshes that were created into the child of your skeletal mesh. You position them wherever you want them to be positioned. And then over here on the parent socket, you socket it to the bone on the skeleton that you want it to follow as far as the animation is concerned. So that's why you see these animations playing. Another thing too is under optimization on the skeletal mesh, you'll want to come down here and make sure you're always ticking the pose and refresh bones. If you leave it at the default, it won't tick if you hide the skeleton. So you need always tick and refresh bones checked in order for these meshes to continue to animate without that skeletal mesh shown. So yeah, I repeated this process for pretty much every body part that I wanted to follow the rig. And the animations aren't perfect, but they're close enough because, again, the body pretty much matched the golem body to a certain degree. And then if we look at the character here, you'll see that I essentially scaled each one of these meshes once I had them attached to the appropriate bone on the rig to match. So if these were still like a scale value of 1, it would not have matched as closely because the scales were a little bit different on the textures in the sprite sheets. In the logic, what I did, again, I copied this over and made it compatible with 3D movement. You can also reference the third person character for movement. I also pulled this camera input back so that I had camera control. Again, the input was adjusted, so I had that input. I left the invert character stuff in, and I created these 2 new events to handle side view and front and back view. And I took the Y value, and I said if it's greater than 0, then I'm going to be walking into the depth of the scene, and we want to show the back of the head, and we want to hide the front face mesh. This guy here, we do not want it showing because that's the back of the head. And then we also want to make sure that the visibility of the face side, which I have as a child here, is set to false. So if I come here, we set that to invisible. Let me find visibility real quick. And then we set the face side to visible. You'll see that essentially what's happening here is we're toggling between these two states based on if you're walking forward, you don't have anything. If you're walking into the camera, you have your front face. And then if you're walking sideways, you have your side face. And along with the head swapping out, and you'll see I didn't have to change the head material. I was able to, the head mesh, it's just one mesh, which is this mesh card here. Because this is essentially a plane, we were able to just swap the mesh, the head mesh, the original head mesh with the new material right here to get it to toggle between the back of the head, the front of the head, and the side of the head. I don't know why the side of my head is named head 1, but that's essentially what it is. It just needs to be renamed. So we're sharing the same mesh card, which we can go look at that so I can show you. You'll get a better understanding of what it is. So this is the head front static mesh. And then if we take the material for the, let me rename this guy, so M head side. If we take the material for the side of the head and we slam it on there, you'll see because the mesh is encapsulating the entirety of what is needed for the material, you don't have to worry about swapping the mesh out. That's just the way that this works. So we'll delete this out of the scene. So I would essentially rinse and repeat this process for each one of the body parts that I would like to change. Like, so his body would show his back. So if we went and looked at the mesh parts here, or should I say the textures that we imported, the back of his body would be here. So we would do the same thing. We would just create the sprite, would rename this, drag it into my sprites, body back. We're going to convert it into a static mesh. I do that because it's going to give me the separate material that I need. I don't really care too much. These guys are so closely related that, like, if I was to bring, I need to rename this, rename to body back. So if I was to bring this mesh card front end and then I was to slam this back material on it, you can see they're compatible with each other. You don't really have to do anything crazy. We'll move this into the materials folder. We'll go back to the character. And then on the place where we're handling the front back view, we would go find that body, which is here. And we'll move this down a little bit because that's just the face visibility. And you see where this is like setting the SM head material. We would essentially copy both these nodes, paste them here, wire them up to true and false. Wire this back up, pipe this into the target, and then because we know this is head back, we need body back, and then because it's head front, we need body front, or just M body. And then if we test, you can see it flips the body back around. We walk this way, it flips it back this way, and we're good. So hopefully this has been helpful to you guys and has kind of answered the question of, a couple of people have asked like how you would handle that with this plugin and system. In the future, some people have asked how, oh yeah, I probably need to cover the direction. So as we rotate the camera around, you'll notice that the character's always facing the direction of the camera, no matter what. And that's what gives this illusion. So if that didn't happen, and we'll go to Tick real quick. So if I killed Tick, and I rotated around the character, just like the previous one, it would kind of kill the illusion that you're trying to portray here. So that we're not doing this when we rotate this camera around, you essentially on Tick need to treat the character's mesh, the inside component here on this character, like a billboard. And you need to get only the Z or the yaw value and subtract a -90 from it so it corrects its orientation after it gets the player camera manager camera location and then finds the look at rotation value. So you get the look at rotation, you correct it by -90, and you put it in the set world rotation. And then on Tick, as you rotate around your character, it will keep the Z value of the character facing you, so you don't kind of kill that illusion, and you keep the, you know, you kind of now add the support for 2D character in a 3D world. So hopefully this has been helpful, guys. I know there's been quite a few of you that have asked about how to do this or go about doing this. It's rather simple. You know, this is what, like up, down, left, and right. So it's a 4-directional setup. This can get pretty elaborate, especially if you want to like rotate the camera all the way around the character. And you want, as the character rotates, let me see how to explain this. As the camera rotates around the character, instead of the character remaining front facing all the time, you want it to transition between side and back, like as the camera comes around. So you want it to portray that the character is static in the world, but you're blending between these states on the rotation. That's a little hairy. I may do a future video on how to cover that as we rotate the camera around instead of always so you would still billboard the meshes towards you, but you would have to come up with a material function or a collection, and you would have to detect the the position or the angle of the camera and then lerp between textures on your material to give you the side and back based on the angle of the camera to the character. So like the cards, the meshes themselves will always face towards you or the camera as you rotate around, just like this. But you would lerp between each one of these states based on your static position of what you are saying your character is facing in world space, if that makes any sense. Let me see if I can explain this in a better way. If I eject from my character, he is facing this way in the world. That, you know, based on his perception. When I rotate sideways like this, the mesh card's going to rotate with me. But I technically should then, if I go back to him, be seeing him from this angle, from the side. And then as I rotate around the back of him, I should be seeing him from this angle. There is a way to do that. Fake pseudo 3D effect. But it is a little bit, it is more complex and complicated. And it also introduces a situation where, depending on your character's rig, the side view of him could be, instead of a front-facing view, let's see if we have a side view of the body. Instead of it looking like this and you have a thicker side-facing body view, which uses the same mesh card, you could have a thinner mesh card with the shoulder in the center, which means now that your skeletal structure has changed and your control rig would need to be updated with basically a proxy to control the bone location as you rotate around different angles. So that explains why I haven't gotten off into that, because the plugin, there's not like a one size fits all. There's no way for me to speed up that kind of workflow. I can offer you tools to kind of like speed up the rest of this, and offer you conversion tools to get you from sprites into meshes, into skeletal meshes, to do all of the 2D skeletal work. But depending on the rig or the structure of the 2D character you're working with and the way his modular pieces are made, there's not really a one size fits all to give you like a 4-directional, a 6-directional, an 8-directional. Believe me, I've looked into it multiple times. But if I do come up with some way or some tool to speed that up, I will likely add it to the plugin at a future date. So keep these questions coming, keep the suggestions coming. I do want to say thank you. If you haven't already, hit that like and subscribe button. Consider joining the Wildlife Studios YouTube channel. And until next time, guys, toodles. Happy developing.